This is an elevator ladder logic diagram, a simplified 3-floor lift running live as a PLC program. A call button is lit, the car is moving between floors, and a door timer is counting down. By the end of this video, you'll be able to build this exact program, rung by rung, and explain every contact on it. It is a favorite PLC training example because it packs 3 big ideas into a handful of rungs. So let us rewind, wipe the diagram clean, and build it from the very first rung. Before we touch a contact, here are the 3 ideas this program is built around. The 3 things a PLC student really needs to take away. First, latch calls. Every floor button seals itself in, so a quick tap is remembered until the car actually serves it. Second, direction with an interlock. There is an up contactor and a down contactor, and each one holds the other's normally closed contact, so they can never be energized at the same time. And third, stop at the target. The program compares where the car is to where it has been called and decides, go up, go down, or stop and open the door. One honest note before we start. This is a clean teaching model, not a real safety-rated design. A genuine lift adds a car safety chain, an overspeed governor, door edge detection, and a lot more. We are building the control logic so the ideas are clear. Here is the machine we are controlling. A single car in a shaft, 3 floors, and a small set of inputs and outputs. On the input side, 3 call buttons, 1 per floor, call 1, 2, and 3. And 3 floor switches, at 1, at 2, at 3. Limit switches that tell the PLC exactly where the car is right now. On the output side, an up contactor and a down contactor that drive the hoist motor, and a door output with a hold timer. That is the whole job of the ladder. Read the buttons and the floor switches decide and drive the motor in the door. Rungs 1, 2, and 3 are the call buttons. 1 rung per floor, and they're all identical. Take floor 3. Off the left rail, the call 3 button, a normally open contact. In parallel with it, a normally open contact of the call 3 coil itself, the seal-in. Then, in series, the F3 floor switch as a normally closed contact, feeding the call 3 coil. Tap the button and the coil energizes. Its own seal-in contact snaps closed, a second path around the button. So you can let go, and the call stays latched, the car remembers it. It only clears one way. When the car actually reaches floor 3, the F3 switch opens that normally closed contact, drops the coil, and the seal-in springs open. Served and forgotten. 3 floors, 3 identical latches. Now the decision. The floor switches tell us where the car is. The latch calls tell us where it is wanted. Compare the 2. If there's a latch call at a floor above the car, we need to go up. If there's a call at a floor below the car, we need to go down. And if the call is at the floor the car is already on, we stop, open the door, and clear that call. That comparison is the entire brain of the elevator. Above means up, below means down, here means stop. Everything else is just wiring that decision into 2 motor contactors and a door. So here are the 2 motor rungs. Rung 6 is up. In series, a contact that is true when there is a call above the car, then a normally closed door contact. No moving with the doors open, then a normally closed down contact, feeding the up coil. Rung 7 is down, and it mirrors it exactly. A call below the car, the same normally closed door contact, then a normally closed up contact, feeding the down coil. Look at those 2 interlock contacts. The up rung carries downs normally closed. The down rung carries ups. Whichever pulls in first, its normally closed contact opens and blocks the other from ever energizing. Up holds down out, down holds up out. They can never both be on. Let's watch that logic actually run. The car is idle on floor 1, nothing lit. Now, someone on floor 3 presses their call button. It latches, and the lamp stays on. The program compares. The call is above the car, the doors are closed, down is not energized, so the up contactor pulls in, and the car rises. It climbs past floor 2, still going, until the floor 3 switch closes. The moment it arrives, the call clears, up drops out, and the car stops exactly on target. Call decide, move, stop. The whole cycle in one clean pass. The instant the car arrives, the door opens, and this is where the timer comes in. Rung 4 energizes the door output on arrival and seals it on. Rung 5 is a normally open door contact feeding an on-delay timer, a TON, with a preset of a few seconds, the door hold time. While the door is open, that TON counts. When its elapsed time reaches the preset, the done bit fires, and its normally closed contact on the door rung opens, dropping the door output, so the door closes. And here is the safety link. Both motor rungs carry that door contact as a normally closed, so the car simply cannot move while the door is open. The door has to close, and the hold has to finish before up or down can pull in again. Let me come back to that up-down interlock, because it is the rule you can never break. If up and down were ever energized together, you would be commanding the hoist to drive in both directions at once, stalling the motor, tripping the drive, and in a real machine risking a dropped car. It is a genuine hazard. So we interlock them electrically. Each direction rung carries a normally closed auxiliary of the other, exactly like a reversing motor starter. And on real reversing contactors, that electrical interlock is backed up by a mechanical one, a physical bar, so both contactors simply cannot close at the same time. Belt and braces, because the cost of getting it wrong is a broken machine or worse. Let us slow down the arrival, because stopping cleanly is the whole point. The car is climbing toward floor 3 with the call latched. The floor 3 switch closes, at 3 goes true. Two things happen in the same scan. On the call rung, at 3 is a normally closed contact, so it opens and drops the call 3 latch. The call is served and cleared. And with that call gone, the up rung loses its condition and the up contactor releases, the motor stops. Then the door rung sees the arrival and opens the door. The floor switch is the single input that turns moving toward a target into arrived, stop, and open. Now watch the finished program run end to end. Idle on floor 1. A call comes in from floor 3, latched. Call above, so up pulls in and the car rises. It arrives, the call clears, up drops, and the door opens while the hold timer counts. Mid-hold, someone calls from floor 1. That call latches and waits because the door is still open. The timer finishes, the door closes, and now the call is below the car. So down pulls in and the car descends. It reaches floor 1. That call clears, the door opens again, and the car settles back to idle. Latch calls, a direction interlock, stop at target, and a door timer, all working together. And none of this is abstract. Every symbol is a part on a real lift panel. The call coils are the latched hall call push buttons in the landing fixtures. The at contacts are the floor limit or vane switches down the shaft. The up and down coils are the reversing hoist contactors in the machine room, and the normally closed interlocks between them are that mechanically interlocked contactor pair. The door coil is the door operator open command, and the TON is the door hold timer, a dedicated relay on an old panel or just a timer instruction inside the PLC. Read the ladder, and you are reading the wiring of the panel. So there it is, an elevator ladder logic diagram, the whole simplified lift controller in 7 rungs. Every call button latches with a seal in. The floor switches clear the latch on arrival. A simple compare picks up, down, or stop. A hard interlock keeps the two directions apart. And a TON holds the door before the car can move again. Want to go deeper? I have full builds on start-stop motor control, on a traffic light state machine, and on the Star Delta starter. The same contacts, coils, and timers in different combinations, all linked below, and they all sit under the ladderlogic hub. And to run this program scan by scan, with the calls latching and the contactors switching live, our sister PLC simulator does exactly that. Open the free editor, drop in the contacts, coils, and a timer, and build this lift controller yourself. The link is in the description. Subscribe for a new diagram explained every week, and I will see you in the next one.